So this is the power transformer out of my Vectrex console, and it shut itself down while I was playing a couple of days ago, and I did some voltage checks and there was no voltage coming out of it. There was 220 volts going in, and the way this transformer is set up, it has a center tap on the primary, so it accepts 220 or 110, I guess, because the white wire, which is the center tap, was not connected to anything. It's just left floating on the small board with the fuse, and 220 volts comes in to the red wire and the black wire. The secondary winding shows virtually 0 ohms resistance from center tap to each of the wires, so the winding is fine. The primary winding, however, I'm going to show you here. Put this thing on ohms. See if I can do this while filming. No, I probably won't. Six ohms from the red to the center tap. We should have another 6 ohms right here. We have, it's jumping around, 150k, while back ago it was measuring 900k, so it's kind of an intermittent open. Probably the two wires are barely touching. So as you can see, this red wire is the start of the winding, and the black one, it comes right, or it's the opposite actually. This is the end of the winding. The outer layer of copper goes to this wire, and this one goes right to the start of the winding, so it's where it is burned, from between these 2 points. So it's not a matter of peeling some insulation and removing a couple of turns. This won't work here. So I went to my junk stash and found this. I picked this up because the core of the transformer is pretty much the same size, and I measured it, and by applying 220 volts to the primary I get 17.5 and 22, and these 2 windings are independent, so it was almost a perfect fit, but it doesn't have the center tap. Primary windings are made of many turns of thin copper, and secondary ones contain a few turns of thick copper, so I can easily unwind this and make a center tap and rewind it again, or I can open up this one, cut this thing in half, remove the primary and stick this primary in here. I think I will start by dismantling this one first. If it goes wrong, I do this one. So the way you do this is you get a nail and a hammer. You see these little small sheets of metal right here. Put the nail like so, and you hit it. You hit it and you will remove the individual sheets and set them aside. At the start it will be very hard to remove them, but once you start removing a couple of them, the core will start to get a bit loose and it will be super easy. Let's continue. So I measured the DC resistance of this primary, and it's 39 ohms. And the DC resistance on this side here is 6 ohms. 6 plus 6 would equal 12. So I really don't know if the wire gauge is different. I don't know if that primary will fit right here and provide the correct voltage on this secondary. I remember that now that I'm halfway dismantling this thing, I will dismantle it anyway, and I'll try to unwind this, see what I can do. So this is almost fully disassembled. Now it's starting to get real easy to separate the pieces. They're a bit glued together. So as you can see, the transformer is made out of E-shaped sheets of metal stacked like this. One like this, another one like so, and then another one like this. And here on the space between them you stick these I-shaped pieces. So once this is repaired, hopefully, you start stacking the E-shaped pieces, one to the top, another to the bottom, one to the top, another to the bottom. And then on these remaining spaces, like here, you stick the I-shaped pieces. The first two pieces were incredibly hard to remove because they were tight and glued, so I damaged this one and this one. Shouldn't worry too much about that. It's not that the transformer will saturate by lacking two sheets of metal. You need to concern about vibration, because if the core is too loose, you'll get a horrible humming noise. So after this thing is all tightly packed and repaired, hopefully, I will dip it in varnish to stop vibration. So check this out. After peeling the outer tape or insulation right here, I found these two copper legs. I twisted them together, and now we got 65 ohms from here to here, so the transformer is now fine. Immediately after I saw this, I thought thermal fuse, yeah, and that's probably. You can see there two legs going to the back of the winding, and right here we probably have some type of thermal fuse to protect this thing. Funny thing, and I don't understand why, is why do we only have a thermal fuse protecting the 220 volt side? Why do we have this center tap if it's not used? The center tap has to be for 110 volts, but why isn't it protected by the thermal fuse? That's strange and odd. I really don't know why. Well, I just bypassed it. I'm going to solder it and leave it like this. I did here some calculations. I'm no engineer. My experience is only practical. I have a lot of practical experience repairing stuff, but zero calculating power. So if you find here some rough mistakes, never mind. So we have 220 volts on the primary, 18 volts on the secondary. Dividing one by the other gives us a 12.2 turns ratio. So we have approximately 12 to 1 turns ratio. We got a fuse protecting the primary side on the Vectrex of 250 milliamps. 250 milliamps multiplied by our turns ratio gives us a maximum current of 3 amps, 18 volts at 3 amps on the secondary before the fuse pops. So it's not really a massive amount of current for wire of this gauge. Not that it will start a fire or something, because the transformer is all metal encased. It's not like this one. It has metal covers all around it. So I'm going to leave this thing bypassed. If there's an overcurrent situation, the Vectrex will probably not work fine, because it will load down the voltage. If there is a short, it will probably break a winding. So I really don't care. This transformer was expired anyways, and I bet it will serve me for quite a few years. So now I'm going to put it all back together. This was all unnecessary work, because this thing is facing upward, facing to the front. It's right here. So I could have just peeled this plastic off and repaired the transformer without disassembling it. But yeah, I forgot to check that. Because if I have 20, according to the Murphy's law, if I have 20 broken transformers, the ones that I peel the tape off will not have the thermal fuse exposed like this one. And if I don't peel the tape off in one of them, that's when they will have the thermal fuse exposed, and it would be easy to repair. So yeah, let's reassemble this thing and put it on the Vectrex again and play some games. So I got my soldering iron heating up. See if I can make a big hole in the carpet. And first thing I'm gonna do is solder this, set it aside like so. Not gonna bother to put a wire on the center tap, because I will not be using it for anything. It's not connected to anything on the Vectrex. So I'm going to set it like this. I'm going to wrap this thing with a couple of turns of paper tape. Then I'm going to solder a new black and a new red wire, which I have them right here, salvaged from an old TV. I'm going to wrap a couple of more turns of paper, and then I'm going to reassemble it. Another thing that I want to add is that this thermal fuse, or whatever that is, most likely did not fail because of heat. Because of the last time that I used the Vectrex, it was working fine, and when it malfunctioned, it did it after maybe 5 minutes of playing. So it's probably something to do with the age of the component. Got deteriorated. This may be a common fault, because I see a lot of people on the internet complaining about broken transformers on their Vectrex. They even try to source new transformers, so before you do that, make sure you try to repair the old one, because sometimes we think we are doing something good, putting in a new part, but most Chinese parts are rated at some type of rating, and that rating is false. They don't withstand the current that they say they do. The 18 volts, I don't know if it's the output without load or if it's measured with that specific load. You may end up buying a transformer which outputs 18 volts and then under load it goes to 12 or something like that, so it may create instability problems. Don't forget that you have a CRT inside that thing and also a logic board powered by the same transformer. I don't know if the center tap, one side of the tap is for the CRT and the other for the logic board. I really never studied the diagram to check that, but it's possible that the full 18 volts powers the CRT and then 9 volts from one of these branches powers the logic board. Maybe it goes to a 5 volt regulator or something. I haven't looked at it yet, but sometimes repairing the original transformer would be the best choice, better choice than buying a China transformer, because for sure it will not give you unexpected results. It will either work or don't work. If it fails, if this repair fails, and if the transformer overheats and melts, whatever, then I can go and buy a Chinese replacement. I bet one arm and one leg as this thing's gonna last for the remaining life of the console. So and if it fails, if it ever fails, I will make sure to get that on video so that everybody knows that I failed. So after stacking all of the E pieces, you want to start stacking the I pieces on the hole, on the space available, these slots right there. Don't worry if they are not properly positioned yet, like this. Don't worry about that, because when we stack them all, we're gonna hit them with a hammer and try to make the core all smooth and square. By hitting it with a hammer, I don't mean hitting it very hard, just tapping it. It will not take much force to straighten the core because it's not glued. I don't know if I'm gonna go to the trouble of dipping this thing in varnish or not. I was gonna do that because I thought I had to unwind the primary, and if I did that, it was best practice to either use new wire, which I don't have at hand, or if we are reusing the old wire, which is not advisable to do, I would for sure dip it in varnish. Better yet, if I had a vacuum chamber, that would be even better. But since I did not mess with the windings, I don't think I'm gonna go into that, just because I would have to wait for it to dry overnight, and I really want to play some games today. So the transformer is all put back together. I'm feeding it 220 volts right now. If you want to do this at home, make sure you don't do it on a conductive surface like this. And if you manage to do it on a conductive surface, be extra careful. I can already tell that this thing is working because I can hear it hum a little bit. I'm going to see if the phone captures that. Maybe not, but I can hear it. So let's go to AC volts. There we go. 20. See, it's an 18 volts transformer, but under no load it gives us about 20. So if you buy an 18 volt transformer, probably will not be enough. You need to buy a 20 volts center tap transformer to replace this. But if you own a Vectrex, before you buy a replacement transformer, make sure you go here to this side and peel, or no, this side right here, and peel off this insulation and bypass the thermal protection. Or if you are afraid of doing that, try buying another thermal fuse or something like that you find appropriate, and stick it right here to the core in a suitable place, and there you have the protection, the factory protection. So as you can see, it's working fine. I added a little bit of polyurethane sealer just to add some strain relief to the wires. It's working very well now. It's been on for a couple of minutes. The transformer is cold, but I have been thinking about this for a while, and this piece of equipment has a major engineering flaw, and that is, as soon as you plug the power cord in the socket, the primary of the transformer is always powered, and the power switch right here, although it's a mechanical switch, it only removes power from the secondary of the transformer into the circuit board. So as long as this thing is plugged into the wall, it's always drawing a little bit of current, which is the result of the losses in the transformer's core. So the transformer is likely to build up some heat even if this is not being used. Well, that's not a major concern for me, because I have it stored in a shelf, and when I want to play I have to take it out and plug it, and then after I get tired of playing, I put it back on the shelf, unplug it. So if you want to do a repair like this and want to be extra safe, you can always buy some type of thermal protection fuse and put it right here, glued on top of the transformer case. I would buy something in the range of 50-60 degrees Celsius, because that's a temperature that I don't believe this thing will never get when normal operating. But if it stays plugged in for a couple of months and you forget about it, maybe it can hit that temperature and the fuse will blow, and it will not cause a fire or something. So I'm not gonna do that. I always unplug it. As you can see there, this Vectrex had some shorted capacitors. These styrene ones, somebody has been soldering around them and melted them and they were shorted. I had to replace that a couple of years ago. It's been working fine ever since. So I'm going to close it and enjoy it. So another thing that I remembered is that you can, and I did that, you can add some safety after bypassing the transformer. So here's the way the Vectrex is hooked up from the factory. You have mains coming into the fuse board, from the fuse board to the transformer. So the transformer is always drawing some current, and from the transformer it goes to the power switch and to the logic board. The power switch cuts off the two 18 volt taps, and the center tap is always directly connected to the board. The way I have it hooked up right now is I rerouted the wires, and from the transformer both center tap and the other two taps go directly to the board, and the power switch is now cutting the power from the fuse board to the transformer. Right here we have 3 wires. The center wire, which was the white wire, I removed it. It was not connected to anything on this board. So we got our mains coming in to the fuse board, and if we power it off on the power button, we no longer have power on the transformer. We are no longer drawing any current, and the transformer stays cool. Now let's see if I can play with one hand. Can I do something with one hand? No, I can't. Or maybe I do. So there you go. Safe Vectrex repair, extremely easy, and you can do it yourself without having to buy another transformer.